Hi, this is Dr. Zhuyi Huang, and from Chemical Engineering at Villanova University. So here I talk about module of the data format operation and import and export data. So here's the outline for this module. So you're going to study the data types, right? And then integer, right? And all others types, and then data format and display, and how to record the data in different variables, right? Like scalar and vector, right? And matrix, and also the sum operation for all these variables, and how to save the data, import the data from Excel, and also export the data to the Excel. So I use one example to illustrate all this operation. Right, so we're going to import here. I'll show you more detail here. So you're going to import, you're going to input the data into Excel. So the first column is student ID, and the second one is the math score, right? And then this for physics, right? And this chemistry. So you're going to calculate the GPA for each student. So firstly, you're going to input the data and save in the Excel document, and then you're going to import it into MATLAB, and then you're going to do the calculation. You're going to add one column here. So add one column here, and to save the GPA. And after that, you're going to rank the student in a decreasing order. So the highest score and to the lowest score based on the GPA. Then after that, you could save the rank, the result, and into the document here. Right. So here you're going to run all these functions in this module, and also you should watch the module to introduce the installation of MATLAB, also the user interface and the help and plot function first before you come to watch this module. Okay, now let's talk about the data types. So typically we're going to have integer, right, and floating point numbers. Actually we call the real numbers, and streams and log variables. So here, for example, this is the integer, right, and this is the real number, and this is the string variable, and then this one a equal b equals c. We have double equals here, and this we call logic operation. And also a is larger than b, also logic operation. So for the algebraic operation, we're going to have two results. We're going to have one, or either 1 or 0. 1 means this is true, 0 means that's false. So for example, we're going to practice this one right up. So now let's type it in the command window, so we don't have to put in a function. You put in a function. Okay, so you could put on in the function, or you could just type in the command window, because this is not that complicated. So I just put in the command window. So a equal to 10, so you get a equal to 10, so this is integer, right? Bigger equal it is 10 over 3, so this is a real value. Then you got c equal to, so we had the quotations here, quotation side here, right? So you get good morning. So you got c, right? And then you got, so a, remember a equal to 10, b equal to 3.3, so a equal to b, right? This is logic operation. This is not right, this is logic, see? logic is not right, 0, and A larger than B, this is true, right? And then you get 1, right? Okay, so this the different types of data, right? Format, right? And now so here I also want to show you another one. You can use format to change format short and format long, and this actually is for the display, right? This, so for example, for format short, you have 5 digits. For format long, and we're gonna have 15 digits for the double format, right? And actually it's double precision here. Then for 7 digits for the single precision. Okay. Anyway, this just changed this how the data is displayed and doesn't change the computation, right? So here, so the computation on these float variables, real variables, actually, no matter it's the single or double, they are done in the appropriate floating points precision, right? And so this format just change right, the way to display the data. It doesn't affect the computation. Okay, so the default precision is the double, but if you want to change the single, you just use single, right? And then just type this in the command window, and then you will get changed to the from double to the single precision. Now I want to show you how to show the data, right? If you want to show data, you just remove this semicolon, right? So if you type A equal to 10, I put semicolon, you don't see the A, right? But if you remove semicolon, you can see it, right? This is how the display. At the same time, you also can use display here. This is a function we call displays, and then disp or display, right? There's two very similar function, right? So you could see, you could display this A, you could see the A value, right? Or you could try display A, you also can see the A value. Okay, so this display actually is equal to A, very similar to A equal to 10 without the semicolon, right? This is similar, so it's the same as this one, right? Equal to A, similar to the A equal to 10 without the semicolon, right? So what you ask me, what's the difference between display and also the disp? What's different between these two? So so if B is for B is an empty array, right? You can put an empty array, means nothing there. B empty. So if you type this B, you don't see the value. However, if you just type display B, then you see the value, right? It's empty. So this is different between this and display, right? Typically we use display, right? Okay, so now so hopefully you understand the format and also how to display the variable. Now I want to show you more detail on how to save the data, right? The first one is the scalar, right? And for example, you get 1 and minus 2. It's only one element, right? It's only one element. So for the vector, so we have multiple elements. So for example, we have these elements, right? Okay, and so also here the transpose, right? For example, this V is like a load vector, right? And the transpose of V actually is become a column vector, right? So this is what the transpose mean. Okay. So there's a MATLAB. For example, if you want to type V, right, equal to 1, 2, 3, 4, 5, you could type. You could put the comma here. You could put space. They're the same, or you could put the column here, and 1 means what? 1 means the interval, right? The interval equal to 1. The default interval actually. The default interval equal to 1, or you could remove the 1 because, right, the default interval is equal to 1, so you don't have to measure the interval here. So 1 to 5 means what? Means it's equal to 1. The default interval equal to 1 and to 5, right? So change from 1 to 5, and then the increasing interval is 1, so you get 2, 3, 4, right? Okay. So similarly, for the transpose, you just put the prime here, right? Okay, now let's just practice, right? Okay. Now let us try to type the V in. Okay, so I clean up the command window. So I type CLC. Okay, and then I see V equal to 1, 2, 3, 4, 5. Right? So you get V, or you could remove the space sign here. I remove the comma and use space. The same, or you could use right. Okay, sometimes you don't need to put parentheses here. Okay, so now let's try to use the get the transpose, right? So you get this one, you get transpose. So you could, so before the transpose you get this one, right? And you put the transpose, so you get the column vector, right? So here 2 to 3 means what? 2 means the second and the third elements. The third element of V. Okay. So now the second and the third should be 2 and 3, right? So you can put type V 2 and 3. Okay. And you could, if you want to see the 2 to 5, you get here, right? You get similarly here. The column means the increasing interval is 1, right? Okay, so there's some vector already in MATLAB. For example, you could use 1s and 0. This one means what? So you can see the first element means the number of rows. The second element here, so we have 3 rows. The second element means the number of columns. Right, so it's equal to 1. So we get 3 rows and 1 column. So we get 1, 1, 1. Alright, all values 1. The second, similarly, for the 0 is all values are 0. Right, let's try it. So you get 1s, 3, 1. Right, so it's 3 columns, 3 rows, 1 column. Right, all the elements are 1. So similarly, you get 1, 3, 1 row. 3 column, all values are are 1, right? So similarly, you get 0, right? 0, yes, 3 row and 1 column, and 0, 1 column, 1 row, 3 column. Okay. Okay, now let's move to the matrix. Hopefully, understand the scalar and then the vector. Now let's move the matrix. matrix actually is multiple dimension, right? It's more than one dimension. It's also have multiple elements. So for example, we want to type in the matrix like this, like 1, 2, 3, 4, 5, 6, 7, 8, 9. So you type row by row, right? So this we use the semicolon to separate the row. So this row 1, this row 1, this is row 2, and this is row 3, right? Okay. So this is how you input the matrix. Another one is you input the matrix row by row. So it's here. So M1 and column means what? Means the first row, right? So the first elements for rows. The similar but if you want to get the first column, you're going to put M, right, and column and then 1 here. So this means the first column. So all the elements in the first column. Okay, this means all the elements in the first row, right? So you can type in row 1, row 2, row 3. Okay, and then this 2 and 3 means the second and so the second row, right? So the first index is for the row, right? Remember? So second row, the second index is for the column. So the third column, right? So actually it's equal to M, second row, the third column, right? Okay. And then similarly, we're going to get transpose, right? For the matrix. Also, we have some template matrix used. For example, this one means we can have 3 row 4 columns matrix. All elements are 1. Here I means what? I means unit matrix, right? So here's 3 by 3, right? 3 means 3 by 3. Unit matrix means only the element in the diagonal is 1. All other elements are 0, right? Okay. Now let's practice. So M equal to 1, 2, 3, right? And semicolon 4, 5, 6, semicolon 7, 8, 9. So this M, or you could type in M. I may use M1 as maybe too different, right, from M, right, to show you another approach to so M1, the first so M1, the first row equal to 1, 2, 3, right? M2, the second row equal to 4 to the 6, right? Increasing intervals 5 as 1, right? There we get. Oh, actually, I should this type here should be M1. Okay, now M1, the third row equal to 7 to 9. Okay, you can see M1. So exactly the same as the one as M, right? Okay, so I want to see what is the second row and the third column, right? It's 6, right? Second row and the second row, third column should be 6. Very good. Then I want to see what is the first column of M. First column here, 147, right? And then we'll see the first row. You get M. First row, right? It's 1, 2, 3. Okay, so you could get the transpose, right? Transpose, and then you get 1, 3, 4. So 3 rows, 4 columns. All elements are 1s. So similarly, you get 4 rows, 3 columns. All elements are 1. You get I. 3 means the unit matrix, right? And 3 by 3 unit matrix, and only the diagonal elements are 1. So similarly, you get 0. Now you get 4 and 4. So 4 by 4 matrix, all elements are 0. Then here's 5 by 4 matrix, with elements is 0. Right? Okay. So hopefully you understand scalar, vector, and matrix. Now there's some operation. The first one is simple, right? It's just minus sign, right? Opposite. And here's the power, and then this exponential, the sign, and here you get this one is natural log, and this log 10 means the base 10, right? Log, right? So you could just type in. So for minus 2, you get minus, right? And then like this, the power, right? Then exponential. So you could help, for example, help exponential, and then see all other related function you could use, right? So exponential 1 with this value, right? And sine and pi, right? So you could see help, sine, and you could get all other similar function, right? Okay, and then you get log. So for example, log, this is natural log, so we could do around 1, then this 10 base log, so log 10 base log should be equal to 5, right? Okay. Anyway, there's a lot of for a function, right, for the you could find in MATLAB, right? So MATLAB can be used as a scientific calculator. Alright, so you can see all this operation actually can be also applied to the vector and matrix. Alright, so actually if we used all this function, and then the operation is applied to each element in the vector or matrix axis element wise. Alright, so for example, we want to get a log, right, for this vector, right, and then the natural log, right, and then you will get this value. So we're going to apply the natural log operation to each element in the vector v, right? So we can get v, we get 10, right, 100. I think so you get this one, right? You get log v, right? Or you could get 10 base log, you get, see, 0, 1, 2, 3, 4, right? Okay. Now, so far is only one element operation. Now let's talk about two element operation. For example, the plus, right? So you can see this vector 1, vector 2. So you're going to have the same vector 1, vector 2 should have the same range. Otherwise you're going to add this error, right? The dimensions must agree. So now let's try it. Right, clean out the windows. So v1 equal to 1 and to 5 increased by 2, right? So therefore, see, 1 plus 2 equals 3, 3 plus 2 equals 5. Similarly, we get 2, v2 equal to 2, right? Increasing interval is 2. So we can see v1, v2, they're same length, so we get add them together, no problem. So right, it's element wise. Adding, so 1 add to 2, 3 add to 5, 4, 5 is added to 6. Okay, now let's change to v2, right? For example, change 2 to 6, and now the increasing interval is 1. So this is what v2 means, right? So v increased by 1, 2 increased by 1 to 3, right? And then to 4, and then 5, and 6. Now you can see we have 5 elements in v1, v2. So let's take a look. Let us take a look at v1. So v1 only has 3 elements. So we can do the right, v1 plus v2 because they have different lengths. So you can see. So this is the most common error you can see. Every time you see this means what? Means the length or the size of vectors or right matrices of two variables do not match. Okay, they should have the same length, the same size, right? Okay, good. So similarly for the minus, right? We could do it again similarly. So I just save the time, so I just skip it. Now let's do the matrix multiplication. So you can see this matrix 1, this matrix 2, right? So you can see this the dimension of matrix 1, dimension of matrix 2. So what I want to say is, you can see here. So the number of columns of matrix 1, so we call it M1, should be equal to here the number of rows of matrix 2 equals n. Otherwise you're going to have this, this arrow, right? Okay, I believe you learn how to do the matrix operation in the algebra, right? So I don't show the detail how to do it. By hand, I show you how to do it in MATLAB. So you just type M1, you can type M and N into the equation. MATLAB, you just type and then they could multiply together. So you get M equal to 1, 2, 2, 1, 3, 2. Right, you could solve it and the chart is the same, right? It's right. So you see it's right, it's right. Okay. And then similarly you get n equal to n, right, equal to 4, 6, 8, 5, 7, 9. Okay, so you get m times n. So you get this value, right? Okay, so we could practice this one. You could switch them, right? You could switch these two matrices, and then you could do the practice, right? Okay. Now let's do about the square operation. Square. So for the power operation, we only applies to the square matrix. Okay. So now let's do it. So we could, so for m equal to 1, 2, and then 2, 1, right? So you could get m square, right? So so for example, if m is not a square matrix, for example, m is here is 2 by 3, is too low, 3 columns, right? What you're gonna get? So let's check it. 1, 2, 3, 4, 5, 6. So you're gonna get error, right? Because this doesn't obey the rules here, right? For two matrix operation here, right? The number of the columns in the first matrix should be equal to the number of rows of the second matrix. Okay, so that's why for the power operation we only do that for the square matrix. Okay, now let's do the element-wise multiplication. For example, right here, vector 1, vector 2, we want to vector 1, right, the element-wise multiplication, right? So 1 times minus 1, 2 times 1, 3 times minus 1, right? So you just put, hey, you just need to put a dot in front of the multiplication sign. That's it, right? So we get V1 equal to 1, 2, 3. So now typically I will use the column vector, so I put the transpose here. V2, so typically we represent the vector as a column. So that's why typically we use the transpose here, right? Okay. but for this operation it doesn't matter, right? So you get minus 1, 1, and minus 1. You could use the row vector if you want. So you get v1 times v2. So you can see element-wise operation. However, if you don't put the dot, then you will get error, right? Because now v1 is regarded as a matrix, v2 is regarded as another matrix, right? So the matrix operation have to follow the rule, right? Remember the rule is what? The rule is the number of the columns of the first matrix equal to the number of rows of the second matrix, right? Okay. So similarly for the power, we also can use the element wise. Again, you just put a dot in front of the power size. So since you could just practice it, right? So what happened on this one? Let's maybe try it, right? So we get v1 equal to 1, 2, 3. Right, you got v1, right? The power v1. Again, you also get error, right? So you get, because you get this one equal to v1 times v1 plus v1. So again, this is two matrix operation. So have to follow the rules, right? Okay, now let's do the inverse of the matrix. It's very useful, right? So this inverse of the matrix. Again, the inverse of matrix is only applied to what? Non-singular matrix. So I believe you guys learned from algebra what a singular matrix, right? Singular matrix means what? First of all, this column, this row, right, equal to 2 times of the second row, right? So it means that these two rows, they are what? They are correlated, right? Okay, so we could change one row or one columns to 0 by the linear operation. For example, the first row minus the second, the 2 times of second row, and then you can change to 0, right? So something like that. Anyway, so the singular matrix typically have you just say hey, and 2 row or 2 columns, at least 2 row or 2 columns are correlated, and then for singular matrix we don't have the inverse, right? Because, okay, now but for this one, hey, this is not singular, right? The matrix, so you could use the inverse like IMV to calculate inverse the matrix. Or another way is you using the I means the unit matrix divided by M, right? This is the same as the inverse of the matrix. Okay, now let's practice M equal to 2, 0, 1, and 1. So you get inverse M, this value, or you could try I, just a unit matrix divided by M, like the same. Okay. The application of the matrix operation actually is very useful. For example, we could solve this equation, right? So we want to get S1, S2, S3. So you could represent this as a matrix operation. So A equal to what? So you can see for the first row here, right? So we get -1 for the S1. So this first column is S1, the second column is S2, the coefficient, right? The third column is the coefficient for S3. So we get this 1, this 2 for the first equation. So B equal to the 2, right, at the right hand side of the equation. So similarly, the second row you get 3 -1 and 1 for the coefficients for S1, S2, S3, and then B for the second row is equal to 6, and then for the last row you get -1, 3, 4, and then you get 4 here, right? So therefore you could this A and this B, and then you could use this and to calculate S1, S2, S3, right? The value. Now let's try it. So we could try let's try it, right? So A equal to, right, -1 1, and then 2, and then you get 3 minus 1, 1, and minus 1, 3, 4. Right? So you see the same. Right? You need to double check your A value, right? Then B equal to 2, 6, and 4, and remember this is a column vector. So right, 2, 6, 4. Now we could use right the inverse, x equal to inverse A times B, right? Just so you can get x1, x2, x3. Okay. Now let's do the element wise right array divide. So this the first, so this element, right? So the element in the first vector divided by the element in the second vector, right? Something like that, right? Now let's type it, and then you get this one, hopefully. Okay, so we get v1 equal to 1, 2, 3. So v2 equal to minus 1, 1, and minus 1. v1 right over v2, so you get the value, right? Okay. So what happens if we remove the dot, right? You're going to see the arrow, right? So you try it. So now we want to see, hey, what is the size of the vector and the matrix? So you just type for the vector, you just use the length. For the matrix, you just use the size. And size 1 here means what? The number of row. Size 2 means the number of, so the first of the columns. Okay. Now let me try it for you. So v equal to 0, 1, 3. So get the range v, right? 3. Get matrix. 2, 3, 3, 4. Alright, 4, 5. You get size of m means what? Hey, we have 3 rows, 2 columns. Right? If you want to see the number of the row, you just use size, just the first element of the size vector. Actually, 3 here, right? So similarly, you get size m2 and the number of the columns, right? Okay, so this is more about numerical value comparison. Now let's talk about the string comparisons. So for example, we want to compare these two streams. You see the first one we have what? We have actual space here, right? So string 1, string 2 should not be the same, and then string 3, and this is the lower cases, and right, this is upper cases. So now let's do the comparison. Okay, so now we just type phase 1 equal to love space MATLAB. So phase 1, phase 2 equal to love MATLAB. Okay, and phase 3 equal to left space MATLAB. Okay, now let's compare. So this means what? This string comparison, string CMP means string comparison, string comparison. I get phase 1, phase 2. Actually, not the same. So phase 1 should be the same, right? Phase 1, phase 2 is not the same. Phase 1 and phase 3 not the same. So you can see the space. So the lowercase and the uppercase are not the same in the MATLAB, right? So you can see phase 1 and phase 3 not the same, right? Okay. Now in some case scenario we need to get a name with the string plus number. For example, hey, we process hundreds of fluorescent images. So we get images 1, image 2, and image n, right? So we want the program automatically get the names for all these images, right? So therefore you will have two parts, right? The first one is stream. The second one, 1, 2, 3. There's number, right? So so therefore we're going to make a name to combine a stream image, and then we're going to change, so convert the number. Actually, d means integer, right? Integer. Convert the integer to string variable. Okay. So and then we could make a name, right? We could get a new stream, right? So this one we get a new stream, and then stream have the information of the number. For example, the image 1, 2, 3, 4, right? The number, right? Okay. And then based on that, we could preset. We could change the I, and then we could change the name of the image, and then we could preset the image automatically, right? That's the power of this command. Now I want to show you, right? So you just use this. You just use the string cat, means that we combine two strings together. So we get, for example, we get I equal to 1 for the first image. Then you get name equal to string cat, right? And then you put this image, right, as the string, and then sprint f means we're going to change the, so here is the percentage d means we're going to change the integer value to the string variable, right? And then the second, in the last half of the name of the picture is gpad, right? Okay, so you get, see, this image is a string variable, then gpad is a string variable, and then this we change the integer, the number, to the string. So that's what you get, right? And then if you want to process image 2, you change I to 2. First of all, you change I to 2, and then you run the program again, so you get image 2. So then you can process images, right, automatically. Okay, in the last one, I want to show you how to import the data from Excel, and then also export the data, right? So again, you're going to type this in Excel. So to save time, right, I already have the Excel document here, so I don't spend time here to type in. So here is the student score. So you just type in, right, and save it as student score and in Excel, right? And then I want to show you how to import the data. So here, this is right. You just remember you have to put the Excel in your working folder, right? And after that, you could just get the data in. Okay, so now I want to show you. So now, because we're going to handle the data, so we build a new function. I build a new document, so I plus here, and then CLC means clean the command windows, right? I save it first. I say main I put main import. Okay. So CLC means clean the command window, and then clear means clean the work space, right? So clean all the variables. Okay, I put clean and then I say the data score equal to, right, and Excel read, and then I put the student score, right, and then remember you put the whole Excel document's name here, and then you can see the size of the score, how many students and how many columns, how many rows, and then you see score, right? Okay, save it, and then save it, and then save, and then run it. Yeah, I had not put the matrix into the my working folder, so I save it. So I go to my working folder. Actually, my working folder is MATLAB document, MATLAB. So I save it here. Okay, this time should work. Okay, so it's busy. So you can see this score, right? And we had 10 rows and 4 columns. 1, 2, 3, 4. Okay, now you can see column 2, 3, 4 are the math, physics, and chemistry score, right? Now I want to show you how we're going to calculate the GPA. So here you can see we're going to we only focus on column 2 to 4 because they recorded the score for math, physics, and chemistry. And here means what? The mean means we just we get the mean across the columns. So for example, we get the mean value, right, of the score showing in column 2, 3, and 4, right? So we focus on the column, right? Okay, because for one student, their score is recorded in 3 columns, right? Okay, so now I'll show you. So you could type, and then we add. See, at the beginning, the score only have 4 columns, right? We add a new column, so add a new column 5, and then we put the GPA into the column 5. Okay. And then we're going to rank the student on the base of here. 5 means the 5th column. Okay, minus sign means what? Here this minus sign means decreasing order. Okay, decreasing order. Right, now let's do it, and then you can see the result, right? Okay, now we calculate the GPA equal to mean, right, score, right? And again, every time when you put the parentheses, you put in the pair, right? Then you will not forget one of them. Okay, so 2 to 4 column, and then 2 means across the column, right? And then you get score, the 5th column equal to GPA, right? We add GPA in the 5th column. Then we go rank student, and then sort row. Sort row means we sort each row on the base of right. So we sort each row of the score on the base of the 5th column, right? And then it's decreasing order, so it's -5. Okay, so we typically use sort rows because we want to keep each row no change, right? Each row represents 1 student, right? We don't want to change the information of each student. Okay, now save it, Ctrl S, and then you run it. So you can see, so so this score we add we have add one row, add one column, right? And as a GPA, so this score before we rank the student. Now after we rank the student, we can see the highest score, then the lowest GPA, right? Okay, so this is student index. So each student, the information is no change, right? Good. That's why we use the rank and the sort row. Okay, now we want to save the data into Excel. So you just type this one. Just use Excel write. So you get so you're gonna get Excel write, and then you could get rank okay, go back. You just type in a rank student. So we made a name of the Excel document, so rank student Excel, right? So just type in here. So, rank students, right? Excel, and then here, this is the variable you're gonna save in the Excel, right? This rank student. So you get rank student. Okay. So save it and run it. Right, and then you should have, you could see the Excel here, rank student. You double click it, you see the result. Right? Okay, this is the result. See? Okay, in Excel. We can also save the data in TST document here. So I want to show you. So we're going to, this is the name of the TST document, and here's the command you're going to use to open a new file. So this is the file ID here. So and here is how we're going to write each student's information into the file, right? So here's the name of the document you're going to create, and W means we're going to write the information into the document, and here is F, printf, and to print the information of each student and line by line into the document. So here you can see the percentage sign here means the format, and D means integer, right? This for student ID, and then we have here, and all these 4 items actually they are floating number, so we also can real number, right? They recall this one, they call the mass, this one we call physics, right? And this one we call chemistry, and this we call GPA. And percentage 4.2 F means what? And this, so for example, the student score is 98.0, for example, in the calculation, right? The GPA of a student is like this, and after we apply this format, you're gonna get this, right? So 4 means what? 4 means we have 4 significant figures. Right? And 2 means, right, we have 2 digits after the so here 2 digits after the decimal point, right? So here you also see slash n means what? Means change line. So after we finish entering a student's and information, and then we change to another student, right? And then we change the line, and here's the data of student. So be very careful. We have transpose here, right? And this is specific for it. So this is specific for the TST format. So when we write the matrix into a TST document, the MATLAB going to transpose the matrix. That's why we need to put the transpose here. So after we finish writing, and then we close, here is close the file. Okay.